Hello, everyone. Welcome to today's section. Good morning, good afternoon, and evening to everyone from wherever you are joining us. It's exactly 4 p.m. West African time. Thank you for taking the time from your busy schedule to attend this event. You're all welcome to the Geospatial and Mobility Data for Health Solution in Africa Hackathon series, hosted by Data Scientists Network, formerly known as Data Science Nigeria, in partnership with Meta, formerly known as Facebook. Welcome, everyone. So you drop wherever you are calling in from, wherever you're joining us from, drop it on the chat window. So for our session today, so for this section and for also the hackathon we also did, we practice and build solution on using Facebook mobility data to provide health intervention solution. Now, today we'll be exploring meta mobility data sets and how to apply them to build solution. So our speaker today is someone who works with Metadata for Good team, and he will be giving us first-hand information about Meta's privacy-preserving data. I hope you are all excited to learn today. So let's, for a recap on what we've done throughout our hackathon series. Firstly, we kicked off with a meta class where we inspired and motivated everyone about geospatial data and also mobility data sets in building health solutions globally. This was followed by an introduction to African Geoportal platform where we learned how to analyze this data. So we also had a representative from Esri that taught us how to do this. Next, we also enjoyed 3 weeks masterclass where we ran geospatial and mobility data sets in training people on how to analyze the data using a solving problem solution in English and also in French. So these videos are available on our YouTube channel. Then we also had a masterclass section where we exposed our participants to hackathon best practices to enable us build solution. After the hackathon series, which already prepared our participant mind, we then move further to practice and build solution for health intervention in our local community. Please note that if your submission, if you already done your submission is currently under review and winners will be unveiled at in-country workshop across the 4 countries, that is Nigeria, South Africa, Kenya, and Senegal. With that said, before we introduce our guest speaker for today, I would like to invite my colleague, Anu Yeniro, to talk to us about all the good work we do at DSN. Hello, Anu. Over to you. Can you hear me?
Hey, Wari. Good evening, good afternoon, good morning, everyone. Wherever you're joining us from, this is DSN, as introduced by my colleague, Wari. And so nice to have you, Alex. Thanks for joining us this evening. So without taking much of our time, I'll just quickly run through who we are at DSN. So please, can we move then? So DSN, as Wari rightly said, we are referred to as Data Scientists Network, and formerly referred to as Data Science Nigeria. This is as a result of our transitioning into a global organization, whereby our commitment is now renewed to raise 1 million AI talent and build AI solutions that will improve the life and the well-being of 2 billion people in emerging markets. So that's our renewed focus as we've transitioned to a global firm. And our focus has always been on the use of data and its extension to drive artificial intelligence and address sustainable development goals. So this has always been our focus, ranging from no poverty to financial inclusion, health, gender equality. This has been our focus. So we make use of AI to solve real problems. So that's why we're having a session this evening to also complement that. So without taking our time, I'll just run through some of our recognitions and awards over the past few years that we have come up. So next, please. So GSN work has been mentioned and referenced over 10,000 times in various academic papers curated on academia.edu. So we've been referenced over 10,000 times, and this also testifies to our work on the research, which has been leading everything that we get to do. So also, I would be glad to also mention to us that two products, which was initiated, conceptualized, and developed by DSN, they were selected in the 2021 Global Top 100 AI Products by UNESCO IRCAI, and the two products are EdTech AI Adaptive Learning Engine and Prescribe Right. The AI Adaptive Learning Engine supported over 8 million learners during COVID, while the Prescribe Right is an OCR solution that helps to detect the correct prescription of drugs, as we know that Nigeria and its emerging market are still not, we are still developing. So the digitization of handwriting is what Prescribe Right focuses on. Next, please. So like I said, those two products were recognized. Also, DSN is recognized. We are recognized as one of the top AI startup catalyst platforms in Africa. I mean, you can just see DSN just up there. So we're recognized as one of the top AI startup catalyst platforms in Africa. And MIT, the world's foremost technology university, recognized our work in generating open data. So we're recognized by MIT, and this shows as part of a good work that we're doing. So I would love for us to appreciate DSN in-house. While I'm moving on, please let's celebrate DSN in-house. So also DSN's work was recognized in the UNESCO Science Report 2020, as DSN was recognized as one of the centers, one of the civil society groups that is promoting AI and AI-focused innovation hub, while German Institute of Labor Economics recognized DSN as the #2 AI center in Africa, ahead of many African universities, as this one of the centers that is promoting research and educational development of AI in Africa. So that's one of the good things we do at DSN. Is anyone happy? Let me see your reaction in-house if you're happy that DSN is really making. Thanks, Alex. I can see your hand there. So also, we're glad to be in partnership with two other major universities. One of the universities in Nigeria and the other one in Benin Republic. Benin Republic is just like the next country to us there about here. So we're funded by we're funded on a project called EduAI Hub. So EduAI is Artificial for Intelligence for Education Innovation Research Network in Africa. So we're funded by Canada's International Development Research Center, so Canada's IDRC, on a project as to running and trying to make use of AI for education in Africa. So we're funded by that. That is a testament to how much our work is recognized at the academic space. Also, DSN is recognized as #1 artificial intelligence learning community and solution delivery network in Africa, and this was done when we won the Matai Impact Award at Deep Learning in Daba in 2019. So this is one of our recognitions. Whilst also we won the best academic poster at the 21st edition of the Global Economic and Computation Conference. So we won the best academic poster here. And that poster was basically focused on the shared trust to end poverty and promote financial inclusion. So like I said earlier, our solutions are always focused on the sustainable development goals. So that's one of our good work there. So DSN also is recognized as the only African finalist at the 2021 X Prize competition on building advanced AI algorithm to address COVID-19. So this recognition came at 2020 during the COVID era. So please, can we celebrate DSN more? Let's celebrate DSN. So without taking our time, I'll just run through. This is our lead mentor presenting some of our top accepted papers at one of the foremost AI conference. This is the Triple AI in 2019 rather. So this is one of the good work that we do. So next, please. And to also complement what I said earlier, so some of our leading papers are what you can see on the screen. So you can check them out. It's available on Google Scholar, it's available on ResearchGate, and it's available on GitHub. So they are all out there. And we are good. We're good, and we're proud to have presented all of our works and our research papers at all of these top conferences, all of these global top conferences, starting from NeurIPS to ICML, ICLR, Triple AI, Deep Learning in Daba. I mean, just mention them. So EC20, I mean, just mention them. And good as it were, we are also proud and happy to have partnered. I mean, we have been a strategic partner to all some of these very awesome global, national, I mean, just mention them when it comes to the AI world, ranging from AI for D, that's AI for development, to Zindi, I mean, Black in AI, just name them. So we have strategic partnership with them. And also we have fostered business partnership with quite a lot of global partners. I mean, Meta is one of the global partners which we are happy to be working with. And that is to testify to how much you are really concerned and how much you are committed to raising the 1 million AI talent and developing AI solutions. So among some of the partners that were fostered relationships with, MasterCard Foundation, I mean, World Bank, Vodafone Africa, AI Commons, KPMG, Bill and Melinda Gates Foundation, amongst others. So we've done quite a lot in terms of fostering our partnership with them. And like I said, DSN has footprints all over Nigeria and across Africa and in the UK. So currently now this shows the distribution of DSN across the globe. So this is DSN. We have DSN across the globe with a footprint represented here. So we also have a campus community across all the states in the country. So we are proud to be the largest community holder in the country. So this, we believe, would help drive our vision of raising 1 million AI talent. So also, this is a picture of one of boot camps, AI boot camp, which is referred to as the foremost boot camp in Africa, whereby you can learn. I mean, we bring in the top and the best of the mentors, best and top of students to learn in an all-exclusive event. So we also have a dedicated community for ladies because we are big on inclusion. So we have a dedicated community for ladies called DSN Ladies in AI, whereby ladies are meant to come together, share thoughts. They're exposed to mentors, global mentors. They're exposed to top-notch projects, just as the one we have here, so that we can grow and we can all develop. And we also have dedicated communities for schools. Schools will mean secondary schools, primary schools, so that we can all learn, because we believe that inclusion is all we need to do. I want to drive the gospel of AI across each and every of the segments. So this is DSN at some of the internal displaced camp, whereby we're taking these kids through introduction to AI and how they can use AI to better themselves. You can see these are just examples of the pictures of some of the things that we've done in time past. And over a period of time also, we've done quite a lot of detailed masterclass rather, whereby we've brought together very top persons to come around and lecture professionals, graduates, executives on what AI can do. So my colleagues are already dropping the link for you to check through some of those classes. This is an example of a AI Summit and Executive Masterclass for top and C-level executives across different sectors. Next, please. So like I said, DSN also is very big on startups. So in the case that you have an idea, you want us to mentor you, you want us to incubate your idea, we are open to that, because there's something called DSN AI incubation, whereby you register. My colleague is going to be dropping the link for you to register. You have an idea that you're sure that is worthwhile exploring. DSN is readily available to help you drive that, because that's what we do. And we're good also on solutions. This is an example of the solution that we've released. It's called Spot On. What Spot On does is for you to be able, it helps businesses to be findable, reviewable, promotable, and digitized. And this is done across just one phone number. As you know, unlike the civilized and the developed world, most of the small businesses here are lost because they are not findable. So this is what a Spot On does. So you can just go to your Google Play Store. You can check out Spot on the app. So without taking our time also, next please. So we're just going to be moving to the next bit, which is introducing our speaker. So for you to learn more about DSN, please kindly visit www.datasciencenigeria.org. That's org. My colleague is going to be dropping a URL for you to learn more about DSN. And kindly do also follow us across all of our social media. We are active on Facebook, Twitter, Instagram, LinkedIn. Just follow up and learn all the good work we are doing. Thank you very much, Wari. Over to you.
Fantastic, Anu. Thank you so much for that wonderful presentation. The exciting work that DSN have been doing over the years. Like, I'm really motivated. So without further ado, I would like us to introduce our speaker. So let us meet Alex. Alex is a research manager at Data for Good at Meta. Alex Pompey, like his full name goes, is a research manager on Meta's Data for Good team. His team builds privacy protecting data sets to assist with natural disaster, public health crisis, poverty, and climate change. Previously, Alex led the growth team at a startup, scaling the company to 35 countries over 3 years. And now, prior to this, he had worked on access to information and internet program for 6 years at an international NGO called IREX, first in Ukraine, next in Namibia, and then in Washington, D.C. And also, he also served as a Peace Corps volunteer teaching mathematics in Namibia from 2006 to 2008. Alex also holds a BSc in physics from the University of Illinois and an MSc from the University of Michigan, where he taught astrophysics. He has served as a guest lecturer for the University of Maryland School of Information. What a wonderful portfolio. Let's all welcome Alex on our chat window as he begins his presentation to showing us all the good work he's been doing at Meta for Good. Hello, Alex. We are so glad to have you here. Welcome.
Thank you so much for the warm welcome. Thank you so much, DSN Africa. I'm truly humbled to join you remotely here from the US. We're facing a lot of snow where I am at in Detroit, so I'm a little bit jealous because I think some of you, although I did see it's also very cold in Africa this time. So yeah, I will just share my screen. We'll switch over. I plan to leave plenty of time for questions, but you can please use the chat to ask the questions while I am speaking so that none of them get lost. My goal today is to give you an overview of the Data for Good program at Meta and those data sets which are using artificial intelligence the most that we are building, and those especially to focus on the privacy protections that we are applying in these data sets so that it either might be useful for your own work or as a learning tool to understand the cutting edge of privacy protected methods. I won't be able to cover all of our Data for Good program in our short time together. You can reach us on our website, dataforgood.facebook.com, but I'll also be leaving my contact details on social media or my email address in the chat before I leave. I would love to connect with all of you in the future. So today you can think of me like you are coming to a restaurant, and instead of serving food, I'm going to be serving you data. Data for Good at Meta is a pretty big restaurant, so we have 3 different menus. We have our MAPS menu, that is our breakfast menu. It is morning where I'm at. Breakfast, we say, is like the most important meal of the day. So it is our largest menu. It has the most options, and we'll spend the most time there because it is most pertinent to your focus on artificial intelligence. Our lunch menu should not also be forgotten. We are covering surveys data in this section, and I will share with you some of the findings from one of our most recent climate change surveys that I think is very interesting for the continent of Africa. And then dinner, we won't have time to eat dinner together today, but you can find out more information about our Insights for Impact program on the website or connect with me later in case you're really hungry for that meal. So the items that I'll cover in my presentation are the ones with the orange arrows. These 3 data sets, the high resolution settlement layer, the relative wealth index, and our social connectedness index are all available fully publicly. We release our publicly available data sets on the UN's Humanitarian Data Exchange. It's often called HDX. I'll be sharing QR codes that you can scan with your phone, and we can drop the links into the chat. You can be downloading these data sets and starting to work with them even as I'm talking. It's not like a practicum exercise today, but I just don't want you to feel any barriers to getting your hands on data. That is the most important outcome we can have today, is if you try a new data set, you look at something new, and you have some questions. That would be success for me. We also offer some controlled access data sets. I won't be covering them today, but if you see anything on our website that sounds interesting, you can reach out to us through there or through the contact details that I'll be sharing. These are available to vetted nonprofit institutions and academic research institutions. And we have the necessary agreements in place with over 650 of those institutions around the globe. So it is highly likely if you yourself are a student or a researcher or faculty, or you are working at an NGO, we already have agreement in place with your organization and it covers that entire one. Or we can work on a new agreement to get you access. It's usually less than 2 pages. It should not be a large burden. And then the preview for our lunch menu, we have these large surveys that cover a wide range of topics, from economic and small business and SME development to social connections, survey on gender equality, 2 very large COVID surveys, the COVID-19 Trends and Impact Survey, we think is the largest survey in human history. It had over 170 million responses starting in around June 2020 for the next 18 months. Today, we'll just focus a little bit on this climate change survey that I'm very excited to share with you. And then we will skip dinner today. So the first data set, this is our special. When I saw your work at DSN to be focused on the UN Sustainable Development Goals, I was very happy that this would be the first data set that I would speak of. Our high resolution settlement layer is really in many ways the denominator for how we would measure success for any of the Sustainable Development Goals, because it is a population density map. If we want to make progress on the Sustainable Development Goals in a given country or a given region or even a small town, we need to know how many people we think are living in that place so we can assess our progress towards those completion of goals. So this is a global layer of population density available at 30-meter resolution. And I'm going to focus today on the privacy and the AI methods we are using to create this population data set. So we are going to start with this. You can imagine we're in an airplane or we are up above. This is a village in northeastern Namibia where I lived as a teacher for some time. We are looking down. And what we want to do is take this large image. It was taken from a satellite orbiting the Earth and purchased from the company Maxar. And what they do is stitch together the images from different days to get a cloudless picture, because on many days there might be some clouds that are blocking the view. And now what we are going to do is take this image and break it into 30-meter by 30-meter sections. And each of those 30-meter by 30-meter images, we are going to train a machine vision algorithm to detect if it thinks there is a building in that place. It's very similar to what you might do if you're standing on the tall hill or in the airplane. You look out below you and you say, oh, that is a road, that is a field, that is a tree, and that is a building. And we have this very nice causal relationship. Human beings, we tend to live in places where we have built structures. We are not just living out in the open. So if we find all the places where we see buildings from above, then we know that that will be an accurate way to distribute the population for a global layer. So let's see how this method performs. So now you can see where our algorithm is quite confident. It has seen a building. All of these purple squares are 30 meters by 30 meters. And we have colored them with based on the density of how many buildings it thinks it can see inside that 30-meter square. In this rural area, it is only really detecting 1 building per 30 meter. We're not in like a dense city or things, so you will see all of the colors are the same. Now, this takes some time, right? Like even if you were a person and we were showing you one image at a time, 30 meter by 30 meter, and you tell us yes or no, the computer can go much, much faster, but the globe is very, very large. The total image for the entire globe is around 1.7 petabytes. So even having the storage capacity to hold that giant image is something that's very difficult. But for Meta, we have many data centers that are very large. And so we are able to do this to not only store the image, but break it into the 30 meter by 30 meter sections, and then very efficiently run our AI algorithm using MapReduce methods to detect, to give us its confidence if it is detecting buildings there. So here's what that image, the giant 1.7 petabyte looks like, but we are looking just at Africa. And now I'm going to snap my fingers, and the data centers, it took longer than this, but now they are checking. So it has done that same thing we did in the small village, and it is coloring each of the 30 meter by 30 meter tiles based on how many buildings it thinks are present there. And then we can remove that background image. We no longer need it. All we care about is that density. And now we have this map of the density of buildings. And what we do is take the projected census estimates from our research partners at Columbia University's CSIN group. They are the world's foremost experts on predicting what would the results of the census be in a given country if it were to take place this year. So maybe there hasn't been a census in a given country for maybe 10 years, so we need to correct from that previous census. They will look at data from maybe smaller scale household surveys for other projects. They use a variety of sources and they predict what the census outcome would be. And we take that data, and instead of taking the census counts and distributing them across an entire census area, we are only going to put the people from the census count into these 30 meter by 30 meter tiles where we have detected a building with our algorithm. And we aren't going to just do them uniformly. We are going to do it according to the density of the buildings. And the nice thing about this method, and we can see here zoomed in into Nigeria, is that all of the disaggregations that come from the census, we can bring them forward into our maps as well. So if the census has a disaggregation for only persons above the age of 60, or maybe only females versus males, maybe only youth, we can bring those forward as well. And so here we can see a map of Nigeria, but we are only looking at the population over the age of 60, which in the context of COVID-19 response is most important, since this population has the highest probability for mortality from the disease. So maybe you're getting very excited now. I see that you've been doing some trainings where working with Esri, or maybe you're using other geospatial tools. So this is a little bit advanced, but the cleanest way to pull this data, it's on HDX as both CSV files and GeoTIFFs. You can also, if you are building your own application, maybe you are like one of those startups that was mentioned by the previous speaker, you can fetch it from our Amazon AWS S3 bucket very efficiently. It does not bill you, it will bill us. And these are pre-rendered type of file format called a cloud optimized GeoTIFF. So you could be pulling from this data every time that you wanted to be running a zonal statistics calculation in your application. And it will be both fast and it will not cost you anything. The types of, again, I'm not going to go into full details. This might be a little bit advanced. You can go to HDX if you just want to download in your browser. But you can use the GDAL Translate library. Scan the QR code in the upper right. We produce tutorials here. If you would like to get familiar with this and you are building an inline application and you want to be pulling from this API, which is my preferred resource for using these very large data sets without incurring costs or storage difficulties. So we are moving along quickly, so to leave time for plenty of questions. Like I said, you can be dropping things in the chat and we'll revisit those once we get to the end of my presentation. I want to share with you next our second data set in the breakfast menu, our social connectedness index. This one is very exciting because really it's only possible for Facebook to build this since we are the world's largest social network. So what is a social connectedness index? Well, what we can do is let's take all of the countries in the world, and we are going to add up the total number of friendship ties between the any two countries of all of our Facebook users. And then we normalize that. The denominator is the total number of users in both countries. And we scale it back between a number of 1 and a billion. So the two countries on Earth that have the most total friendship ties between our users get a score of 1 billion. And the two countries on Earth that have the lowest number of total friendship ties between all users get a score of 1. And then we fill in that distribution for all country pairs on Earth. Now, we don't need to use just countries. We could also use the next admin level down. It is arbitrary to our spatial designation that we want. Countries is just the easiest way to think about it. We release 6 different versions of it at different administrative levels and for different areas on the Earth's surface. And so this should be very useful and adaptable, not just at country level. We're also taking some steps to preserve user privacy. You may have heard the term differential privacy. That's kind of a fancy way of saying, hey, when we are aggregating some account, like these total number of friendship ties over a unit, we want to add some random noise to that total so that we can make sure that it is proportional to the maximum contribution that a single person would be able to make to that data set. So if the noise that we add to our aggregation is at the same proportion as a single user's maximum contribution, that means if we took the user away, we are not sure if it was the noise or the user leaving. And this is a simple explanation of the concept of differential privacy. So the methods we are doing to ensure that standard of differential privacy, measuring the statistical re-identification risk within a data set, we are going to remove those areas, those countries where we have few active users. We are going to add this random noise count to the number of total friendship ties. And then we are also going to do this 10 different times. We are going to make the calculation shown in the formula 10 times. And each time we are going to leave out a random 1% of Facebook users. So all of this is doing is just adding a lot of randomness, but in a very methodologically prescribed way so that we can quantify the statistical re-identification risk according to differential privacy. I could spend our entire time together just on this concept, but I just wanted to give you a quick overview. There's many papers that you can find on our website that go into more detail. And I'm happy to follow up afterwards because this is my main area of research. So now let's have some fun. Let's actually look at the social connectedness index data. So like I said, we can build it according to countries. And so I've chosen Nigeria. And I want to color the world according to which countries have the strongest social connectedness index to Nigeria. And it is maybe not surprising, the country that has the highest probability of relative friendship amongst all Facebook users with Nigeria is Nigeria itself. This is true for every country on Earth. People in Nigeria are most likely to have Facebook friends who are also from Nigeria. But then as we start to look outward, and we can see the colors on the map, we see some very interesting trends that might be useful for different applications. Let's dig into those now. Oh, sorry, before we do, I want to point out also, we can look at not just at the country level. Here we can look at the top social connectedness index values between counties in the United States and Nigeria. So you can see here Prince George's County in Maryland in the United States, which is right outside Washington, D.C. So I think there's a lot of diplomats and things. There's the highest probability that a random person in that county will have a Facebook friend in Nigeria over any other county in the United States. And we can color the entire map of US counties in the United States according to the social connectedness index, as you see. So now, why might this be useful? There's many different applications. I'm sure some of you brilliant individuals will think of even more, but I want to share some that we are currently aware of. So let's say we have this graph of all of the countries on the Earth. Each country is a node, and the social connectedness index is the edge between them. And I want to reduce the Earth complexity from 200 or so countries. I will say I only want to consider 30 countries. And I want to join and cluster the nodes according to the social connectedness index. What would the world look like if we are mapping according to social connectedness index and we want only 30 clusters? That is what you are seeing here. So we see some very interesting dynamics that describe both the social isolation and common ties that are forming across the Facebook graph around the globe. And this has been used to study many different phenomena. The most likely or obvious one is international trade. How much trade is taking place between given countries? And here you can see the strength of the predictive quality of social connectedness index, how much that relates to trade between two countries compared to other more traditional economic measures. We have things here like sharing a common official language, having a border, being on the same continent or same subcontinent. And we can see that social connectedness index is actually one of the strongest predictors of international trade, even more strong in many cases than these more traditional economic indicators. Also, this social connectedness index has been found to be very predictive of how diseases spread. So we look here at this county in the United States, Westchester County. It was where the first COVID case in the United States was reported. And then we look at how COVID-19 spread across the United States. And we don't care about the distance between Westchester County and other places. We don't care about physical distance. We care about the friendship distance, the social connectedness index distance. And so you can see on these graphs the very strong predictive quality that this spread of COVID-19 took. It tends to spread according to social connectedness index in a very predictable way. So it's very useful for AI applications for forecasting the spread of disease. You'll find many papers from epidemiologists who have used social connectedness index in their AI forecast models throughout the pandemic. So maybe now you're getting excited. You want to order this from the menu. Like I said, we are releasing these data sets on the UN's Humanitarian Data Exchange. You can see the URL and the QR code in the lower right. You can download, you can read stronger documentation. You can read the original publications, the scientific papers that we have published for these data sets. And you can also connect with us to ask questions. I'm going to start moving a bit quickly. So next, maybe we want to map not just where people are living, like we did with high resolution settlement layer, but maybe we want to map where wealth is distributed, and the inverse of wealth being poverty. That is our relative wealth index that we also release. So here I want to show you the picture first because that's the most fun. The more orange an area is, that is the more wealth we believe is concentrated in a 2.4 by 2.4 kilometer tile. The more purple, the more poverty we believe to be estimated there. How do we make this map? How do we make this calculation, this prediction of wealth distribution? And zoom in a little bit so you can see the granularity, the transparency here. So the areas that are very clear or like silver gray, that is where our AI model has the most uncertainty. Whenever we are making predictions like this, it's a big challenge, but it's very important to communicate uncertainty in predictive models. So we are trying to visualize that as well. And it is a lesson I hope you take with you as well. The data set itself, when you download it, it looks very simple. We have this quad key value, which is the unique address of each of the 2.4 kilometer tiles, the latitude and longitude of their center. And then our relative wealth index prediction, it is just a number between -10 and 10. The higher the number, the more wealth we believe is distributed there. And the lower the number, the more poverty we believe is concentrated there. And then, like I said, we also produce the error or the uncertainty that our model has in its prediction. It's very important to communicate and to quantify this. So how are we making this prediction? What we are training our AI to do is to estimate what the results of a particular subset of questions from a survey would be. This survey is called the Demographic and Health Survey, the DHS survey. It is funded by USAID. They've been running this household survey for many years. It's a very long survey. It takes about 90 minutes if someone comes to your home and asks you a series of questions. And some of these pertain to wealth. And it's, do you own television? Are you cooking with wood? What is the material of your floor? Do you have electricity? And each time someone answers these questions, like, oh, yes, I have electricity, I have television, it adds a positive value. And maybe if they are cooking with wood or other indications of poverty, it is adding a negative value. And the total sum of these, like around 60 or so questions related to wealth, you just add up all of the positive numbers and all of the negative numbers, and then you get a relative wealth index. Now, unfortunately, it's very expensive to run this household survey, so the USAID cannot send someone to every house or even to one house in each 2.4 kilometer square on the Earth's surface. So we are training our algorithm to predict what this outcome of this survey would be in each of those squares. That is what the relative wealth index does. I won't spend much time here because it sounds like a lot of you have a lot of background in AI, but what we are going to give our model to learn is a series of input features. Things like population density that we know for that square, the wireless connectivity that we know from that square from Facebook users. And when we take those two things, we can make a prediction of what the relative wealth index would be in that square. Now, we don't need to just have two input features, an X and a Y axis. We actually are going to use around 25 different input features. They are shown here. So these are almost entirely fully public data sets that we gave our model, our AI, to learn from. And let's take a look at which ones are the most useful for predicting poverty and wealth distribution. So you can see that this connectivity data that we have of Facebook users is one of the most powerfully predictive input features for our model's accuracy. So we have data on the number of mobile devices we estimate are in that 2.4 kilometer tile, the number of Wi-Fi access points, and the breakdown of iOS versus Android. But then we also use things like nighttime lights, satellite imagery of how much light is coming from the place, the population density of the place, and then other features that we detect from both geographic, demographic, and satellite features. So then how do we know that our predictions are accurate? Well, what we can do is compare our relative wealth index predictions to the relative wealth index calculations that come from census data. And we've done this for 15 different countries from all around the globe. Sometimes the census is pretty out of date, but overall here you can see across a range of countries and a range of population sizes, we are seeing a lot of agreement between our prediction and the observed or measured relative wealth index from census data. We also have been doing this in some countries that are, I think, of keen interest to many of you attending today. We are using independent survey data provided to us in governments in Nigeria and Togo. And we did these same comparisons, but across a much wider range of community sizes. And again, we can see, we're very happy with these results. For a global layer to make predictions that agree closely with a household survey of this size is very nice. And then we also work with the international NGO Give Directly, which did very, very focused individual household surveys in several regions in Nigeria. And we compare our predictions to the relative wealth index using their data. And again, we find nice agreement that we are comfortable with to release the data set, and then the paper to be published in a strong journal. So you might be very excited. You want to use the data. You can scan the QR code here. You can see the URL at the bottom. Our humanitarian data exchange page includes this data set as well. Now we are moving to the final course in the menu today, our climate change opinion survey. We fielded this survey to Facebook users across over 200 countries and territories in 2022. And I'll just share with you some results. Maybe this is going to be some interesting input data to your AI applications, because it's a unique reach that we have with over 3 billion Facebook users on the globe. So we're asking a series of questions related to climate change that was designed by the Yale Program on Climate Change Communication. They are the world's foremost experts in assessing people's attitudes and practices related to climate change. They've been doing this using a wide range of survey methods for over 10 years now. So here you can see that list of around 200 countries and territories and the number of respondents that we had, that they saw the option to participate in the survey at the top of their Facebook feed. And so then let's dig into the results. So here, first we can assess people, how many people respond that they know a moderate amount or a lot about climate change. We can see the results here shown, that it is very heterogeneous across the world, how much people on Facebook respond and assess their own knowledge about the topic. We take statistical corrections like inverse proportionality weighting to correct for bias in our sampling. So we know that not everyone uses Facebook. We know that it tends to be younger populations in most countries. In some countries, there can be a lot more men than women who use Facebook. In other countries, in Brazil, there's many more women than men who use Facebook. So we can correct for those using these types of methods. So we're making predictions here. You're seeing the results that we estimate if this was a survey of the total population. We also can ask people to assess how important they think this issue of climate change is here. And now we see there's actually kind of a flip. The places where people were saying maybe they didn't know a lot about climate change are saying at a high proportion that they think it is a very important issue. Now, we can also ask, do we think that climate change should be a top priority for the government in your country right now? And again, we see that the world map begins to change. Now we see even more homogeneity, that many, many people in most countries, except maybe places where there's wars like Yemen, are reporting that they think this is a very high priority that their government should be concerned about. And then we can ask people to their willingness to participate and take action themselves to address climate change. And we see the world flip again. We see here that the willingness to participate and take collective action is strongest in Africa. It jumps out. So I know we've been brief. I want to save time for questions and also give you the opportunity to connect with me. I'll leave my details in the chat. You can go to our website, dataforgood.facebook.com, to see all of those data sets, which I didn't cover today, or to get more details on this brief overview that I gave. And you can scan the QR code here to go to our humanitarian data exchange and download all of the data that I showed you today. So I thank you so much, and I look forward to your questions and to connect with you in the future. Thank you.
Yeah, awesome. Thank you, Alex, for the wonderful presentation. I hope everybody learned a thing or two from the various meals they served to us: breakfast, dinner, breakfast, lunch, and dinner. Yeah, I think I enjoyed mostly the breakfast, where you use population data to understand poverty level in different locations in Africa. Great work, Alex. So if you have any question for Alex, you can drop the question in the chat window, then Alex is going to take your question. So, okay, before that, then there's a request for the presentation, for your slide presentation after this, Alex. So we would like you to share your slide after this presentation so we can share to our participant. Awesome. So that's been covered. So any other question for Alex? Okay. Okay, it seems everyone was clear about your presentation and did have question. It seems your presentation was clear and straight to the point enough. Cool.
Yeah, maybe I can ask myself a question about the privacy. So the data sets that I described when we started with high resolution settlement layer, the privacy protection there is like one of our first principles for privacy. And I'm not saying this is like that it is a recipe or a prescription that everyone should follow. Every data set and every application that you are trying to build, you need to weigh the privacy versus the potential efficacy and weigh the ethics of this. So I'm just kind of sharing my stories. I'm not trying to tell you the recipe. So one of the first principles we use is data minimization. This high resolution settlement layer, we are combining the power of AI on satellite imagery with census estimates. We're not using any Facebook data at all. We're using our computational abilities to bring those two things together. This principle is data minimization. If we don't need the Facebook user data to make these maps, we shouldn't use it. We try and minimize the extent to which someone's privacy might even be needed. So that principle is sometimes the simplest, but also it's the most important. Let's minimize how much data we're using. We often can get very excited about all of the data we see around us, but if we minimize, keep it simple, we're often also advancing privacy at the same time. The social connectedness index, I went in depth about this differential privacy. This is a very structured way of statistically quantifying re-identification risk. And what my lesson there would be is that it's very important to probe. If someone just says, oh, this data set has differential privacy, that really doesn't say anything. They should be willing to publish and describe in mathematical terms values such as the sensitivity, the sigma sensitivity, or the epsilon nature of the aggregation and the added noise. That is the actual quantification. It would be like saying there is fuel in the car. You don't know if it is a full tank or if it is right about to end. You need to actually quantify. Give me a percentage. How much is left? That is what you need for differential privacy. So we shouldn't hide behind those buzzwords. They're very popular right now, but we should probe. We should be the ones demanding more transparency. And then in relative wealth index, we are applying the privacy principles that household survey data that we used, the DHS survey from USAID. That already has a lot of randomization that takes place. You also could see that there were tiles when we showed on the map where they were empty. That is where there are too few people estimated to be living there. And so we removed them from the data set. You also saw that there were sensitive countries removed from many of the visuals I showed today, places where there might be wars or conflicts. We can just manually take those out as well. So sometimes doesn't need to be super fancy or sophisticated or like mathematical privacy protection. It's kind of more common sense. We should bring all of those things together. Yeah, so we publish a lot about the privacy protections. I live within the privacy org at Facebook, at Meta. And so it's very important for us to share knowledge, not just about the data itself, like these are very useful data sets, but to learn from one another how we are all protecting privacy and having those discussions so that we can have, advance ethics at the same time as we are advancing data science. So this is another lesson I hope to give.
Awesome, Alex. Privacy is a very, very important thing which we should also consider. So we also have some questions from our participants. So there's a question here. So how can we have access to some of the control data, example, Facebook movements, to help governments real-time decision and health intervention, especially on beneficiary mapping and hotspot, etc. So how do we so did you get a question?
Yes, I do. So you go to our website, dataforgood.facebook.com. You can see all of the different data sets if you click on the tools page. And then at the bottom of those, it will either link you to the public place to download it, or for the controlled access, it will have a form that you will fill out with some basic info. It will be sent to me or a member of my team, and we start that process of determining the appropriate data license agreement. So those fully public data sets have kind of like Creative Commons or open source licenses, so you can just run with those. The controlled access ones have this 2-page terms of service, like data license agreement, which describes we have to make sure it's like the right form for your location because each country has different laws. But like I said, we have agreements signed at an institutional level with over 650. So we are pretty good at this time to add people quickly. And that goes directly from that form you fill out on the website to myself or a member of my team, and we begin that process. So hopefully we keep it simple. We get to the fun part, get the data in your hands. Those use cases that the question mentions is exactly, you can see on the page on our website, we link to all of the publications and case studies and media articles that have used that data set where the authors have consented to us showcasing their work. So you can learn about all of those, what other people have done with the data in the same type of applications that you have. So you could filter Facebook population and health and see the list of the case studies where the authors would like to be featured. So hopefully we help you connect with others as well to build on each other's work.
Beautiful, beautiful, Alex. So there's also another question here. So how can meta privacy preserving technique be used to protect sensitive information in data sets while still allowing for useful analysis and solution building? So the question has to do with using this privacy data also to build solution while hiding sensitive information.
Yeah, I think the important piece of that question is the definition of sensitive. So there's a societal context, different societies or even different legal frameworks have different definitions of sensitivity. And that sensitivity of the privacy also needs to be weighed against the potential benefit that comes from using the data. So it would be one thing if we're saying like, oh, we want this data set because it would be interesting and we can publish a paper. That's a good reason, but not super great. Like a higher bar would be, we want this data because then we can use it to save lives. And we expect that, 1 million people's lives might be impacted by it. So this is to say, I want us to be like very specific on both sides of this ethics. We have the privacy and we have the potential efficacy, and we need to consider those on a case-by-case basis. There isn't a singular playbook across the board that says this privacy level is always sufficient, or this outcome or this benefit for society is always enough that it means we can use any data we want. No, we need to be very specific. I want data set X for application Y, and then we need to come together with a data governance structure, not just private sector, not just the data suppliers, not just the academics, not just the government, but we need to be communicating to one another and make that the call on ethics as a governance structure together, because I can be the expert on the data that Meta has, but I am certainly not the expert. I cannot tell any of you what the benefit would be in your country, in Nigeria, if you had that data set. You need to tell me that, right? So we need to come together and make this call on ethics. And we should do this on a case-by-case basis on both sides of that. So there's not like a set playbook. And I think that is what we're seeing a trend towards is moving towards these more specific conversations. We're not just talking about, the word data is just a big variable, right? It's like it can mean anything. So we want to get more specific about both the data, what it entails, what the risks are, and what the potential applications and outcomes and how likely those are to be. And that requires a data governance structure that is very diverse.
Awesome. So we all have a few questions, like 3 questions more. So I'll go with this one. So what are the long-term implications of using meta privacy preserving technique for healthcare and social good use on the economy, society, and politics? So what's the long-term implication of using this privacy preserving data in solving issues?
Yeah, I think it depends on the data set. So some of them, we try and be, like I mentioned, very specific. This data set is designed to help with X. For instance, this is a survey on climate change. not just like a survey about all the UN Sustainable Development Goals. So we tend to try and build data sets that are specific to a particular type of application. There's a few like high resolution settlement layer or relative wealth index. They have a lot of different applications, but they only kind of graduate to that level after we have done a lot of work. So those are some of our longest term projects. So a lot of them are not going to be super long-term. Like many of the data sets were kind of designed mostly to focus on COVID-19. Data for Good as a program at Meta started in 2018. We're only 5 years old. The company overall is only 15 years old, really. So we're still teenagers. So there's, I think, a lot of how we consider long-term is where we're moving with the program. So we started with natural disasters. Those tend to be, very defined. Many of them only last, a few weeks. And then we moved into public health. That's a little bit longer term. Then we moved into poverty. That's a longer term problem. And now we're moving into climate change more and more, which is on a very long term. So the trend that I'm moving us towards is data sets that can be helpful for the longer term, but those are much more challenging to build. It takes a lot more time to see progress and assess to what extent you've been helpful there than in like a crisis response situation. But I do think as a program, Meta has seen that Data for Good is more useful for the longer term programs. And this will mean more public data sets and more focused on like societal level things rather than the smaller ones. But we are taking the lessons we learned from the smaller scale, geographic and temporal resolution and starting at the small and getting better so that we think we can have impact on the big. But time will tell. I think it is, anyone would have right to question, are we building the right data sets? We really need that feedback from a community to point us in the right direction because we are not the experts on all of these challenges. We are more the experts on the data we hold at Meta and what privacy protections are needed in those data sets to be ethical and comply with laws.
Yeah, and that answers it. So we also have another question concerning accessibility to the raw data from portal. So it's asking, from which portal do we get raw data for analysis to understand the statistical model for any country related with different social index? So the question has to do with accessing raw data on social index for different countries.
Sure. The social connectedness index, we don't publish that. So the formula for social connect, and apologies if I'm misunderstanding the question. I dropped my LinkedIn at the top so you can connect with me there if I'm not answering your question properly. That formula for social connectedness index, the total number of friendship ties between two countries over the total number of users in each country. We don't publish those input features or like the variables that go in. We are just publishing that result. And that's only after normalizing and then doing those statistical, adding the noise according to differential privacy that I said. So I'm not giving you the data to recreate the social connectedness index. I'm giving you the output. And that's in many ways, that's how privacy typically works. So I'm not able to give you all of the underlying data that went into that relative wealth index prediction, like the number of mobile phones we estimate are in the tile, the breakdown of iOS or things. If we did that, we would be collapsing privacy. It would be very easy to re-identify a person in that data set. And so we would have to add so much random noise to it that the output itself would be compromised and wouldn't, it wouldn't be an accurate prediction. So we have to draw the line somewhere between allowing you to reproduce and see the underlying, but also not compromising the final output according to privacy. And this is what I mean kind of between that trade-off between privacy and efficacy. We need to find that balance together. And we welcome the feedback on our current approach. If you think that we are, erring, typically we are going to err on the side of caution as a data provider, right? Like if we don't have the trust of our users, then they will not use our platforms or our services, and then they will not be represented in the data set. So we have to err on the side of caution, but we welcome the feedback in case we are unaware or we are being too cautious. Again, if I didn't answer the question as you were hoping, you can connect with me and I'd be happy to continue conversation.
Yeah. Okay, so I will just bring us to our last question. I would like how you did the generation of wealth index. Can you explain the process, please?
Sure. I'm going to cheat a little bit. And instead of trying to do it again, I'm going to drop the link to our paper in the journal PNAS. So there's top tier journals are like Science and Nature. This is like what is changing humanity every day. The next tier down, PNAS, is one of the next tier down, the Proceedings of the National Academy of Sciences in the United States. So we have published the paper there. You'll notice many of the figures that from my presentation, they come from that. So you can read the paper, you can connect with myself or the other authors. And I'm going to share with you this now, some links so that you can, if you liked those visuals that you are seeing of the maps, you can play with interactive versions in your browser right now. So that one is for relative wealth index. And then here is for high resolution settlement layer. And that Population Explorer website even allows you to do some simple zonal statistics. So if you can draw your own polygon on the map, maybe you can choose like where your grandmother is from or something. Drop some points on the map, and it will show you the zonal statistics. How many total people does our data set estimate live there? Breakdown of men, women, and these different demographics that I described. So you don't have to go all the way to the raw data. Hopefully these two websites let you play around and visualize. And then if you need the raw data, you can do that as well. We make it available.
Oh, awesome. Awesome. So someone is complaining about the PNAS URL.
Oh no, it is working on my side, but I'm going to drop the name of the paper and the authors, the top authors. And so if you just Google it, it should come up. Apologies if the link is not working.
Oh,
so this should allow you to find it on Google. PNAS is not a controlled access journal as far as I'm aware. It is fully public. You can also go to our Data for Good website. It will link to that, and then we link to all of the other papers that have used the relative wealth index where the author has consented that we would feature it on our website. So hopefully we can get this this broken link out of your way.
Thank you, Alex. Thank you, Alex. So the final question before we leave is how much is this data updated on real time for user to access? So if I go to the website, what date of data would I have? What's the most recent data would I have? So that's the final question we'll have.
Great, that's a very good question. It is different for every data set. So the four that I covered today, the high resolution settlement layer, we update once or twice a year for each country. Whenever we get either new satellite imagery from our Maxar provider, or we get a new census estimate from Columbia University CSUN, or we improve our algorithm's performance. So this usually happens around once or twice a year. And you can see on the Humanitarian Data Exchange when it was last updated, and it also says when we expect to update it. Second one, Social Connectedness Index, we release a new version each year. Relative Wealth Index is totally static. We aren't working on updating it. So that one is probably the one that will get out of date the most. The limitation there is the new training data from USAID's DHS survey. This was really impacted by COVID-19, but maybe starting this year or soon, they will begin collecting more for new countries, and then we would maybe restart this. But right now, we have no plans to update it. Climate Change Opinion Survey. We did in 2021 in around 30 countries. 2022, we did in around 200. And 2023, I'm not sure exactly. We're planning on doing it again, I think in April or May. So that one also is around once a year. The smallest time resolution for our data sets are in the controlled access side. And the smallest of any of them, the ones for crisis response, like Facebook population and Facebook population movement, those are updated every 8 hours, but it's just in the area and time of a crisis, like when there's a safety check on Facebook. So it's not like a global map. It is just in those areas where there's like these particular events. And because it is very detailed over time and space, this is why we have the additional protection of the controlled access mechanism, just for vetted like humanitarian partners who will use the data, who we know will use this data this way. Yeah, I know that's it's kind of different for every data set. HDX has a nice way of cataloging it. You can, if you have a particular item on the menu that you're very interested in, please connect with me and I'll give you all of those, the spatial resolution, the temporal resolution, the update frequency. Yeah, we know these, or you can find on our website.
Yeah, this answers is very well. This is very great. So what we say now is thank you so much, Alex, for this wonderful and fantastic presentation. I hope everyone learned something, because I learned a lot and also motivated to do more with Meta's data. So let's also appreciate Alex on the chat window and to thank him for this wonderful presentation which he has done. Let's appreciate Alex on the chat window. We should think it's been awesome. It's been an awesome session. So
no, I hope to return again, maybe, and I'm very humbled to be here. It's always so nice to end the week just connecting as practitioners from around the world. We live in just this incredibly privileged time that we can all be together from wherever we are at and see and connect and learn from one another. So I'm very humbled and grateful for the opportunity. Thank you.
Yeah, we can't wait to have you again here. Thank you, Alex, for your time.
Bye. Happy weekend.
Alex, happy weekend. Thank you, Alex. Okay, so that was a wonderful presentation from Alex. So we'll be moving on to our future plans and next plans for this hackathon. We've had, like I explained previously, we've had series of events and also series of training, and also our hackathon submissions are already being submitted, and we are waiting to announce the winner, unveiled winners at different country level. So this brings us to the aspect that we'll be having a workshop, and even after the hackathon, also even after the hackathon training series, you can also on your own go ahead to build amazing solution with data. So we'll be having a workshop at an upcoming event. We'll be unveiling winning solutions of hackathon. So we'll also unveil winners. We also be sharing also best practice during this workshop. And also we'll be also unveiling a knowledge book that's going to show you how the basics on how you go through different geospatial and also mobility data. Then also you also have lots of gifts and prizes to be won during this in-country hackathon. So the in-country hackathon will run in 3 different countries. So it's going to run in Kenya, Senegal, and in Nigeria. And it's going to run in Kenya and Senegal on the 11th of February, 2023. And the overall announcement of winning of our final winner, the overall winner for the Pan-Africa winner is going to be on the 18th of February, 2023. So we can't wait to see you guys in our in-country workshop. So I want to thank everyone for joining this section. I also want to say thank you to our speaker for the amazing and the awesome session. We also want to thank Meta, formerly known as Facebook, for the opportunity to empower and make smarter and more driven data decisions that can have social impact in Africa through their privacy preserving data. So I want to encourage everyone that you should ensure you explore other possibilities of data in other sectors, even outside the health industry. So come on, there are more applications to solve using geospatial data, so you should try it out yours. And also, do not forget, again, I want to reiterate that our in-country workshop will be on the 11th of February, 2023 in Kenya and Senegal, and also the grand finale for the overall winner in Nigeria on the 18th of February, 2023. We can't wait to see you all physically. Once again, thank you for joining. We are DSN AI, known as Data Scientist Network and formerly known as Data Science Nigeria. You can follow us on social media and be part of the foremost African AI learning system. we are also foremost AI African Learning Research Consulting and Solution Delivery Network. Thank you everyone once again for joining this section. Enjoy the rest of your evening and have a great weekend. Bye.